In this problem, we're asked to find a common denominator for this expression and to simplify it. We're looking at the difference between two expressions here, two rational functions in fact, and essentially they're just fractions, and we're looking to find a common denominator so that we can perform the subtraction. These two pieces will need to have the same denominator in order for us to carry out this calculation. So to begin with, I would look at these denominators, kind of focus on those, and figure out what they're made out of in terms of products. So I would look to rewrite both of these as a product of simpler terms, and then use that knowledge to build up a common denominator. And the simplest common denominator is the one I always go for. So when we're looking at x squared minus 16, for example, the way to write this as a product would be to go ahead and factor it. I would observe that this is a difference of two squares, so I can rewrite x squared minus 16 as x minus 4 times x plus 4. And again, I could quickly check my work on that if I was not real confident. I could multiply this back out. I would get an x squared minus 4x plus 4x minus 16. And the 4x's would add up to 0, and so I would get simply x squared minus 16. You might want to write that off to the side just to check to make sure that went all right. The other fraction has x squared minus 4x. This is not a difference of two squares, but I do see an x common to both terms. So I would factor the x out. So I would end up with x times x minus 4. And I've at least succeeded in writing these as products. There's a product of two things here and a product of two things here. My common denominator then is going to be sufficient to include all of the terms in these two, and I don't necessarily need to repeat. This one needs an x minus 4 and an x plus 4. This one needs an x and an x minus 4. So you notice that the x minus 4 are common to both. I don't need to include two of those over here. If I did, then the result would need to be simplified later on. So this is an efficiency thing. I'll put in one of the x minus 4s, the x plus 4 that the first one needs, and the x that the second one needs. All right, that's going to be my common denominator. Now, what I do next is scale each of these denominators up to include all of the terms in my common denominator. This first one is missing an x, so I'll introduce an x here. And so that I'm not algebraically changing the expression, I will multiply the numerator by x as well. So essentially I've just multiplied by the number 1. Whatever was up there to begin with needs to be left up there. That's an x. And so I'm now going to multiply these two fractions together, and I'll wait till the next step to combine those. In the second fraction, there was an x plus 4 in the numerator already. And what was missing from the denominator here, in terms of my new common denominator, is a factor of x plus 4. So I'll need to multiply this denominator by x plus 4, and so I will multiply its numerator by x plus 4 as well. So I'm really multiplying again by the number 1, written this special way. All right. Now both of these fractions have the same denominator. The fact that they're multiplied in different orders does not matter. They still come out to be the same. And so now I can start thinking about the subtraction. Once the denominators are the same, we can simply subtract the numerators. So this first fraction's numerator would be x times x, or x squared, and the second one would be x plus 4 times x plus 4. So I guess I could write a square right there if I wanted to. So in terms of the two goals here, finding a common denominator and simplifying, we've completed this one. We now have the common denominator on our fraction. We'll now go after the simplification step, and you just want to be careful here. Something in the numerator can cancel with something in the denominator only if they are factors of the numerator and denominator. Much like we introduced these, canceling is removing these in that same way. So I cannot simply cancel this x plus 4 with this x plus 4 because this numerator's x plus 4 is not a factor of the numerator. Again, a lot of words there, but that means that the numerator is not being multiplied by x plus 4, so I cannot simply cancel. So to simplify, since cancellation doesn't appear to be possible, and when you find the least common denominator it really rarely is, I would now multiply out that numerator and try and combine like terms. The x squared I'll leave as an x squared. The minus sign goes next. And now I need to subtract, so I'll use parentheses, x plus 4, the quantity squared. So I'll go ahead and multiply that out. That's an x squared plus, there will be an 8x, and there will be then a 16. And now kind of looking ahead here, I see that when I remove these parentheses, distribute this minus sign through, the x squareds are going to add up to 0. And what's left over, there may be some factoring opportunities there. So I'll leave my denominator alone and distribute that minus sign in the numerator. So I'll have a minus x squared, a minus 8x, and a minus 16. Be careful, this minus sign hits each term. It's just a minus 1 times x squared, a minus 1 times 8x.